Welcome back, Gangies. We're back once again. We might go dark mode in a couple of minutes or a couple of seconds because viewer hostility is still a very important goal of this channel. But fortunately, today we have a few comments to help us stall before the suffering begins. So that's where we're at. So let's take a look at those comments. We have Sir Palinor with a picture of a beautiful feline. Such a beautiful feline warms my soul. Feels strong, man. At day 32, I didn't even see what it says. Day 236, mans is a legend. I'm just trying to get like you, big bro. Feels strong, man. Yeah, day 236 is crazy. To be honest, it doesn't even feel like we're there. I'm gonna be honest, at this point we probably put in more than 236 hours. We probably have. And we're still dog. So we're still dog water. So maybe there's a way to get better. And maybe that way is continuing what we do now, right? So I'm hoping at day 436 we'll be less dog water. So hopefully we'll be done with the easy problems, but I don't feel like I'm in a huge rush. And I would say 30 minutes is about where we're at with this in my head. So, while I think it makes for a less interesting journey, I really wish around 3365 would have had more to show. But I think this is kind of where we're at. I kind of have to make sure I get those other things that I want to. And part of those things are some extracurricular learning goals, which is much less sexy than being able to solve LC hards by the end of the year. So that's unfortunate. But also, yeah. I wonder when we get to 3-day 365 if it'll be like. Yeah, I'm just hoping by the time we get to 365 we finished all the easies, and then from there, it's only up, right? It's got to be only up from there, so that'll be pretty cool. At least I would hope so. But you never know with these things. I surmise that we'll have to start going faster. If we had kept doing an hour every day, we would have been going much further. But there are other goals to reach as well. And I think we're just setting a small candle to see. Hopefully, I mean, we're just burning a leaf a day, right? And hopefully we'll get to the tree. Or maybe it is exactly like a fire, right? If we burn a couple leaves, hopefully it exponentiates the fire entrapment ratio, if those are even words, and hopefully the tree burns pretty quickly. But yeah, I think we're about halfway through, so yeah, hopefully we can keep going. I think it's interesting because I think a couple of weeks ago we were in a kind of a tough spot. I think we're doing better now, so this is good. I think the 30 minutes is what we need right now. I was thinking that I was really tired, but now I'm thinking I was tired. So it takes a lot of executive function to do a lot of this nonsense, on top of working other personal goals, as you all know as well. So sometimes we just got to play the cards we have instead of the cards that we want. So I don't have a lot of executive function, so I have decreased the time we've been doing daily, which is unfortunate, but a necessary evil. But thanks for the comment. That was awesome. And then we have another comment from Saleh Akram Joy. A cool name and an even cooler profile picture. How do you manage your time? Can you share your daily routine for maximum productivity? This sounds like, it's funny. This sounds like a title for an Ali Abdul video. And it's funny is that I actually click those videos. So I think I've been exposed. Manage my time. I'm not exactly certain. I think what I try to do is I try to work. This is going to sound very ghetto, but I try to work with a, oh wait. I try to work on a lightning strikes kind of basis. Well, at least I did in the beginning. So I try to do, usually my things try to revolve around doing something every day. And that doing it every day usually helps me find the right state to be in to attack it. So in the beginning when I started, I used to have to be in a very specific mindset to do LeetCode. And there was like a state transition issue where let's just say I'm in relaxation mode after I finish work. I don't want to transition back into having to focus on something. And similarly back and forth, right? When you're in the zone, when you finally get in the zone at work, you don't want to have to transition into something else like a meeting or a call or something else, right? And I would say that the time management is, I don't really do anything in the same time frame. I just kind of set goals for the day. So I try to do 30 minutes of LeetCode, and sometimes that's later and sometimes that's earlier. But I always try and strike once I get the spidey sense. So I'll get a lightning strike sort of thing going on where I'll be sitting on my couch for a second. I'll be like, I feel like I could do LeetCode right now, or I feel like I should do it. And then I'll just take that emotion and run with it and like hurry up and like start doing it before I lose it. I would say we're no longer like that because I think we've done it so many times now, or showing up every day made it easier to no longer have to do that, because I think the cost to change states was much higher. Because once I'm in relaxation mode, you definitely don't want to go to another mode. But after doing it every day, I was like, it became easier to transition between states. So now I could be like, oh, I'm working, work's done, let me do LeetCode. Or I was chilling on the couch, let me go do some LeetCode before it's too late. So it became easier to switch between states. That being the case, I would say for maximum productivity, I'm still optimizing this, but yeah, I would say the daily thing works for me. The daily thing with whenever I can fit things in. So I try to do the same things every day, but they're in different orders or they're for different lengths. So some days I might do an hour and a half of LeetCode, but I only do 20 minutes of like AWS, but then I'll do like 3 hours of drawing instead. Or I might spend a lot of time working out. I might spend a shorter amount of time working out, a much longer time reading, and then a shorter amount of time doing LeetCode. And I think that variability really helps, because a strict schedule thing, I tried to make it work, and it just made me not want to do anything at all. So this is kind of where we're at, and I feel like the variability allows for some choice. But also the fact that I have to do everything daily makes it so that I have to hit every box. So it kind of works for me. Now I'm curious. What about you, brother? Now I am curious. Oh yeah, so I would say yeah. So I have like a bunch of tasks I track in a Streaks app on my phone. I have a bunch of tasks that I try and do every day, and then I try and make sure I do them all every day, and then that kind of works somehow. The issue is that there's never really a day off, which it kind of is balls, and they can kind of seep into each other, which is why I think that the variability of length, I only set like a minimum instead of a maximum. So if I'm reading that day and the reading is going, if the book is an absolute banger and I end up reading for an hour and a half, then I'll set lower goals on the others. But all across the board, all of the goals are already kind of small. So the workout length is like 5 to 10 minutes on the worst day. But usually it's much longer than that. But on the days where I just can't muster a lot, then 5 to 10 minutes is fine, because eventually we'll get around to doing it as normal. So I generally try to do a little a day. It goes a long way. It will remain to be seen. I think it does. I think I'm downplaying it. It works well. It works well for me. I'm curious to know if it would work well for other people. But I think the setting the minimum goal thing was really helpful, because I would set the minimum goal in the perspective of a maximum goal. So like I would say like, oh, I'm gonna do 2 hours of LeetCode every day, hands down, no questions asked. Then after you do that, you don't really want to do anything else. Or I would beat myself up on days where I only did an hour and a half, and I, pulled back those ridiculous goals and just put them back. A good few weeks ago, I'd say before we went on the trip, I would say minus 2 weeks ago, we were doing like an hour and a half every day. And I think with the changes recently, they've cut out some LC time, which is fine, I think. But that's where we're at. And I think, yeah, that seems to work for me somehow. I'm not exactly certain why, but it just do. But yeah. So, but I think we're going to jump into the LC for today. We were able to dunk on a couple of problems. Also, shout out to everyone who commented today. It allowed us to stall, and now I'm kind of feeling like I'm ready to cook. So let's see how many problems we can get through. We're going to do our standard 30-minute banger and see how things go. There's a robot starting at position 0, 0. The origin, there's a robot starting at position 0, 0, the origin on the 2D plane. Given a sequence of its moves, we're going to have an array of points. Judge if this robot ends up at 0, 0 after it completes the moves. Interesting. You're given a string moves that represents the move sequence of the robot, where move sub I represents its ith move. Valid moves are R, L, up, and down. Return true if the robot returns to the origin after it finishes all of its moves. The way that the robot is facing is irrelevant. True. R will always make the robot move to the right once. L will always make it move to the left. Also, the magnitude of the robot's movement is the same for each move. It sounds like what we really have to check here is if we end up with 0. If the magnitude of the direction, if the magnitude of each movement is uniform, so it's always going to be 1. We can view up as +1 and down as -1, right as +1 and left as -1. So I think what we're actually checking is whether or not enough movements, for every right movement we make, do we have a countering left movement? And for every up movement we make, do we have a countering down movement? So if we move up 9 times, no matter the order, we should always move. Wait a second. It depends on how the robot works. Well, it depends, I guess. But yeah, there should be a counter force of down movement. So it feels like what we're really checking is that for every up, we have a corresponding down, and for every left, we have a corresponding R. I think to check this, we could do this. We could load all the characters. We could load for each direction, which would be a key, which would be L. We could map it to an integer, which would be how many of them exist. And we could simply check whether or not up equals down, and the occurrences for up equals down, the occurrences for left equals right. So we'll start them off. We'll start it off with an array of tuples. Actually, it might just be easier to just start it off like this. We're going to map a string to a number. Say map.set L, right, equal to 0. We'll do this 3 more times. Up and down. And then the goal here will be to do for conster of moves. We're going to say value is going to be equal to if map.has dir, right? Then it's going to get the value of dir. Otherwise, it's going to return 0. Then we can say map.set for value +1, and to check if map.get L equals map.get. And map.get up equals map.get I'm not sure what's happening, sir. I'm not sure what's happening, but map.get D. So let's see if this makes sense. Nice. Feels strong. Feels strong indeed. So let's try sum of unique elements. You are given an integer array nums. So you have an array of numbers. The unique elements of an array are the elements that appear exactly once in the array. Return the sum of all the unique elements. I see. Okay. So we'll just use the map again. And we'll just do for constant map. We'll say map.set. If the map has a value for num, right, then we're going to get the value for num plus 1. Otherwise, we're going to set it to 1. And then from here, we can say let sum equals 0 for const. Then we'll only add the values to the sum if its occurrence equals 1. Oh, maybe we don't understand the problem. Oh my god. I just realized the mistake we made. It should be sum plus equals num. So it looks like we've already done some of these, luckily. We're still ducking on projection area, because that one seems crazy. Try to determine whether matrix can be, check if it's a straight line, and smallest range. So given two n by n binary matrices, mat and target, return true if it is possible to make mat equal to target by rotating mat in 90-degree increments, or false otherwise. Interesting. So here we're going to be performing a matrix rotation. I don't think we've ever done that before. I don't think we've ever done that before. This seems like a matrix rotation sort of thing. I feel like the thing to figure out would be how to rotate, to figure out some sort of formula to rotate. Okay, we're going dark mode. Figure out the formula to rotate the matrix. We have 1, 1, 1, 1. We see that if you're in the center of the matrix, a rotation changes nothing. We have the rows as well as the columns. We have to do something about that. Why doesn't it move if it's in the center? If you are rotating something, that makes sense why it doesn't move. But if I think about this in terms of matrix moving, why can't I rotate this? Or why is it that rotating this it feels like the rotation must be I think any movement that is focused on a particular, or a particular direction must be wrong, right? Because it seems to be relative to the current position of the cells. This cell moves to another cell. Above it. But in this case, it moves to another cell, which is the top rightmost cell. And in another rotation, it would be in the bottom rightmost cell. So I feel like maybe this could make sense if we iterate over the matrix, but swap something. So you have 1, 1, 1, 1 here. Hmm. Okay, it definitely involves flipping row and column. We know this because if you rotate, the rows become columns and the columns become rows. Seems like row becomes column. Row becomes column by row becomes column. If we have row 0, this 0 here becomes this 0 here. No, but I'm confused. It's actually this column. We're in column 0 here. So what does the new column? If the column index here was 0, the new column index should be call.length minus 1 minus call. That puts that there, and if we go to the second column, which is index 1, the column that this becomes is the column here. And then the column 1 here becomes the one here. So column 0 here column 0 here mat dot length minus 1 minus row. So we take this 0. Alright, it's in row 0. It's going to move to this new column, column 1. Now this row 1 is going to move to a new column, which is going to be mat dot length, which is 2, minus 1, which is 1, minus row, which is 1, which is going to be 0. Now we're in the correct column. And now the column, the original column, zero, 1, mat dot length minus 1 minus mat dot length minus 1 minus row, mat dot length minus 1 minus row, mat dot length minus 1 minus row. Okay, and I think the column becomes the row. So let's try a basic version of this just real quick. Right, we're just going to compare two matrices. This is just a simple function that's going to test whether or not both matrices are the same. Right, and at the end, if we make it through without ever returning false or return true, then I'm going to copy this. And we'll make another function called rotate matrix, which is not going to return anything, it's just going to modify it. And we'll say rotations equals 3, right? And we'll say while matrices are not the same, right? mat1 and target at max we should only have to do 3 rotations, and for some reason it's upset about this. Oh, it's called mat. Right, we're gonna say rotate matrix mat and say if pretty much just checking here if rotations are less than 3. We haven't done any rotations yet. We're going to rotate the matrix. We probably want to do it. Probably want to rotate, check if it's the same first. If not, rotate matrix, rotations plus 1. It's less than 3. We rotate again, which means we'll probably have to rotate 4 times total. And I think we just need to implement rotate matrix. And I think we can just put what we had here. And I think we'll try for this tomorrow. But yeah.